Hola, soy Mikel Atxega de Miguel Altuna Lanbide Heziketa.
Yo soy Igor Urquiola de Tolosaldea Lanbide Heziketa Instituto.
Bueno, os vamos a presentar un proyecto que hemos desarrollado este curso 2020-21 y dicho así de manera resumida, lo que hemos hecho ha sido integrar un escáner 3D y un robot colaborativo.
Eso es. Aquí el reto principal ha sido integrar diferentes hardware y software para que sea un producto definido. Sí, por un lado tenemos un robot colaborativo UR y por otro lado tenemos un escáner HandyScan. A su vez hemos intentado integrar mediante fabricación aditiva soportes tanto para el escáner como para las piezas, digamos.
Y el puesto que hemos montado lo que busca simular es pues, una unidad donde se miden reiteradamente multitud de piezas. Bueno, en este caso tenemos un útil que lo que hace es dar apilabilidad al sistema y con esto iríamos midiendo una y otra vez piezas.
Sí, también mediante aditiva también hemos montado una especie de puzzle donde conseguiríamos la repetibilidad de las piezas. Siempre estarían posicionadas en la misma posición y así aseguraríamos que el escaneo es óptimo.
Bueno, y todo el sistema, cómo está compuesto para esa automatización, lo iremos explicando ahora una vez pongamos en marcha el robot.
As you can see, when running the program, the first thing that happens is that the clamping just transfers the piece from the stacking station to the scanning station. Once the piece is placed in the space provided, it is scanned. The acquisition of points that make up the point cloud that reproduces the piece begins. At this point, both the scanning speed and the scanning parameters within the VX scan software have been optimized. The aim is to use the software's own resources to avoid adding scan pieces to the resulting digital file that are not part of the piece, because the digital reproduction obtained should be as accurate as possible. The Handy 700 scanner, combined with the VX Element software, has the particularity of being a laser scanner with great capacity for capturing points and linking shots. It is also essential to use the targets in order to correctly digitize the captured information. The UR5 collaborative robot we are working with provides the ability to reproduce the previously programmed working postures with great precision, with the possibility of adjusting the working speed. As stated in the introduction, significant work has been carried out on the design of various tools and elements that seek to control the location of the pieces and other elements involved in digitizing. All this contributes to ensure the repeatability of the process and so that everything runs safely and under control. Many of the elements have been manufactured using additive manufacturing, a resource that has made it possible to manufacture tools with fully adapted and customized shapes and geometries. In addition, in some cases they have been tinted in black to achieve a greater contrast with respect to the pieces, a circumstance that helps to avoid contamination of the scan mesh obtained. With regards to the automation obtained, the key is to ensure that all the sequencing runs properly. The commands are included in the main program of the robot, but in addition to this, another of the key elements is the I/O module. The I and O refer to inputs and outputs. This module is a software that acts as a translator and a director. It orders when the different elements enter the scene, and also when they have to finish their task. The key is that it has the ability to convert the received signals from the main program into activation or deactivation commands. In addition to managing and sequencing as it receives orders from the robot program, it also assigns values to some of the parameters for scanning. The I/O module is a differentiated software that has been developed by Creform Amatec for its scanners. Besides the software, an I/O module station has also had to be added, a hardware that is an extra control box and that has the task of ensuring correct communication between the UR robot and the Creform I/O module software. The intermediate control box is connected by wiring to the multiple inputs and outputs associated with the different signals of the robot's control box, and in turn, it is communicated to the computer where the I/O module software runs through a network cable. In the images, you can see how once the piece has been scanned, the metrology inspection software in charge of comparing the real piece with the CAD comes into place. The software that has been chosen in this project has been Polyworks, more specifically the Polyworks Inspector module. As in other softwares that work against CAD, the first thing is to align the STL resulting from the digitization with the CAD that is representative of the ideal theoretical piece. All this takes place automatically and in sequence in the execution, as well as the rest of the steps programmed within the inspection program. In this specific case, it has been decided to carry out a complete comparison between the real piece and the theoretical piece, which results in a color map that shows the degree of deviation of the different areas of the digitized piece. In addition to this, the software allows verification either in the form of dimensional or geometric tolerances. All of this must have been adequately programmed in the preparation of the planned tasks. To close the verification process, Polyworks creates a final report associated with the piece that collects everything it deems appropriate.